So this fire safety building code for external cladding system, particularly today I'm talking about BS 8414, the new code to be applied to all external wall cladding systems in our buildings. I think we all know what initiated this interest or this renewed attention onto wall claddings. Just to recap, there is this building known as the Grenfell Tower. It's a residential building in London, a high-rise mid-rise residential building in London. It was built in 1974. It's known as the Grenfell Tower. In roundabout circa 2016, the municipal council decided to give the building a facelift. This building was actually quite groundbreaking. It was built. It's using, I can see, masonry walls and reinforced concrete structures. So it actually looked very nice, very brutalist, in a brutalist kind of a way. But in 2016, the municipal council decided that the building needed a facelift. And this is what happened. Okay, so they cladded the building very nicely, wrapped it all up, made it very modern, kept the existing structures of the building, kept all the existing fire safety provisions and all that. And also to recap, when the building was built in 1974, this building contained only one single staircase in the middle. It's got a single core in the middle, one staircase. And at that time, the old British ordinance, the concept of fire safety in apartments is that every single apartment is fully compartmentalized. That means every single fire apartment is one fire cell of its own. And the principle of evacuation is that you don't evacuate. Should there be a fire, remember, fire can only start at one place at one time now. You shouldn't have the situation where two apartments decide to burn at exactly the same time. So the idea is that because each fire compartment, each apartment building is a fire cell of its own, should that apartment burns lah, it doesn't bring its neighbors down. So the idea is that should the alarm goes off, everyone stay put in your door, keep your front door closed. Everyone just stay put, right? Let the unfortunate apartment burn itself out, but everyone else stay put. That's what the concept is. So fine. So it was built in 1974. Nothing happened all these years. So the municipal council decided that it needed a new facelift, so a new facade cladding 2016, very beautiful, very modern, nice metal cladding, not supplied by Swissmar, and it was built. So less than 1 year later, the building became this. So it was a very, very unfortunate incident. Then, a little bit later, there is this building known as, again an apartment building, a luxury apartment building in Milan, Torre del Moro. It was completed in 2011. Very, very modern building. 2011 is a millennial building. Nice cladding, very neat modernist architecture. And in August 2021, it became this. So there is, it's kind of funny. In the olden days, the buildings are built and somehow they stood. It's not that there's no fires. The incidences of fire have not decreased at all. Right? But somehow the buildings seem to be able to withstand it. But after Grenfell had a recladding, it burned to a crisp. And this brand new building with facade cladding burned to a crisp. So I'll show you a video over here. This is an apartment fire in Benidorm in Spain many, many years ago. Nothing of particular significance here. I just found that this video illustrates something. So this is a very typical apartment building, a reinforced concrete, masonry, brickwork construction. And let's see what happens. Sorry. Thanks. Oh my goodness! Okay, we're on track. Okay, so this, I'll just go to atmosphere. All right, this That's the penance for not subscribing to YouTube Premium. So this is apartment on fire. This is a very, very typical apartment construction, reinforced concrete, masonry, brickwork, very, very typical, central corridors in the middle. Okay, this apartment is on fire. Now look at all these things here. These are actually of course, the awnings. Right? So the fire is breaking out on the inside and it's burning through the canvas awning, burned through, and the smoke is now billowing out. And then we go on to round about approximately here. Oops, sorry. Right, now just watch, the smoke is, all we see is the smoke is coming out. And just hang on a little sec, then, okay, the firemen has arrived, but you can see the firemen are all very chill. They're in no, they're not panicking, they're in no rush, they're very chill. Right, what's happening? Okay, alright then. Did something happen? Just now it was just the smoke coming out, and now, wow, what happened? Okay, this is a phenomenon known as flashover. This is the time where the apartment is really like an oven now. The temperatures have reached probably beyond 300 degrees Celsius already. So flashover is occurring. Basically everything in the room that has got the ignition temperature of about 200-300 degrees is really on fire spontaneously. Yeah? So the entire apartment is on fire now. So the firemen are still kind of chill. Yeah, they're still laying out the hose and so they're still taking out the hose. They kind of chill. They're okay, you know. They're doing their work. You'll be worried if they are panicking. So okay, look at the fire, very, very intensive now. Okay, there's nothing left in the apartment. Everything in there is now on fire. And the smoke is billowing up. Then the fire leaping out of the top. Let's fast forward a little bit. Oh, I think this was the poor resident whom they rescued out of the apartment. So he's watching his entire life savings go up in smoke literally. Now you can see that the fire seems to have died down. Of course the canvas is totally burned. Okay, the firemen finally got their fire hoses intact. But they're not shooting at the fire anyway, you can see that, it's very obvious. He's not shooting at the fire. What they're doing is shooting at he's trying to cool down the apartments above and the structures beside it, the neighbors. You look at the condition of the fire now. Just now when you see the flashover, it was really intense. The fire is really, really burning. Now, the fire is going into a decay. Generally, everything that can ignite has already ignited, and the fire is just now consuming and burning up all the hydrocarbons that's available, and it's now decaying. So the black smoke is still coming, but the fire is generally decaying now. And by about in another few minutes, I really like these guys. They're really chill. You know? They brought in a turntable ladder. They never bother using it. Okay, so this is called flame out now. In other words, there's really no more hydrocarbons to burn, and the fire just flamed out. And what you see are the white smoke. White smoke is basically a lot of moisture, a lot of other chemicals and all that that's gone into the evaporation. And so this is just flaming up. Gee, but all the smoke. And okay, I will stop. These guys are hanging off the balcony. Okay. Okay, great. So a few observations first, right? Before I go on to describing what happened at Grenfell and Torre Balmoral, let's just very quickly visit our UBBL. Right, there is a clause. Just now when you see the fire burning out of the apartment, you can see the fire leaping out and a lot of black smoke. And when the firemen came, they didn't try to put out the fire at all. They were splashing water on the units above. So the first principle is that going back to the same principle as was applied to Grenfell Tower all those years ago. If there's a fire starting at one compartment, you want to keep it in that compartment. You don't want the fire to spread. Right? So if you're unfortunate enough to be on fire, that's your bad luck. All right? But don't bring your neighbors down with you. So that's the main concept. So in the UBBL clause 149, I think we're all very, very familiar with with this. Generally, we do have this provision for vertical and horizontal barriers, 900 mm vertical barriers and 750 horizontal barriers, right? We're all very, very familiar with this. The whole concept is that should a fire burns out, without those barriers, there is this very, very great possibility of the fire leaking back into the building. It's a bit like pouring water off a teapot. Water puts up fire, right? So fire is the opposite of water. Water flows by gravity coming down. Fire, because of thermal, the thermal convection, it goes, basically it points upwards. So when you pour water off a teapot, we always have difficulty in controlling the tea from dripping back on the teapot somehow and then dripping down. The tea, you have to really, really pour it very hard to shoot the water out, to shoot the tea out into the cup. So fire works in much the same way because of a fire is basically burning. So when the surface temperatures reaches ignition point, the surface will ignite. So the idea is that you want to deflect the heat, you want to deflect the physical convection away from the inner surfaces. You want to push it out. So without the barriers, very likely this is what's going to happen. Right? So the idea of having the barriers is that should a fire comes up here, you want to use that fireproof or the non-combustible barrier to deflect the flames, to keep the fire within the same compartment. The UBBL has already got that provision, and of course the other provisions are in terms of our compartmentation, or the separation walls and the compartment walls of every individual apartment. So effectively, our UBBL on a passive system already, well, our UBBL is adopted and adapted from the old British ordinances anyway. Right? So the same concept applies. Every single apartment is compartmentalized on the sides against separated from your adjacent neighbor, and on the back or on the front separated from all the common areas, the lobbies and the circulation. But what happens at the front? We can't have a brick wall, a full fire brick wall in front of an apartment, right? We need our windows, we need our openings. And that's where the 6 schedule comes in. Right? The limitations are how big an opening you have, etc., etc. So what is the difference between the 3 examples that I showed you? Grenfell, it burned to a crisp. Terra del Moro burned to a crisp. But the apartment in Spain, full-fledged flash-over fire in the apartment, all the way from ignition to flame out. Were the neighbors affected? No. The fire stayed in that apartment. So what happened? What is the difference? Right. So going back to Grenfell, I'll just recap the story. I think this one all of us have heard it many times, but just to recap. Okay, the Grenfell building, the fire started on the 7th floor. It started on an apartment on the 7th floor. It actually started from a defective refrigerator in the kitchen on the 7th floor, an apartment on the 7th floor. So the refrigerator, I think, had a short circuit or something, so there was an overload, there was a fire. So a small fire started in the refrigerator. It caught fire on the kitchen cabinets and all that, and the alarm was raised, and the firemen actually came. They came, they went up to the apartment, and they declared that the fire is out. It was a small fire. If your refrigerator catches fire, it burns a little bit, you see a fire, then what do you do? Take an extinguisher, probably splash some water on it, it's out. So the firemen actually came into the apartment and declared that the emergency is over. Then they started packing, and they say, okay, I'll just retreating now, okay, Mr. Apartment owner, go back to sleep or whatever. But then they got a call from the people outside, from the firemen stationed outside. They said, no guys, I see fire on the outside. What happened was that the new cladding caught fire. The fire in the apartment went out through the window, and it ignited the foam insulation in the sandwich wall panel. So that is the thing that was burning. And the fire just went on from there and took down the entire building. Then on the Terra del Moro example, the fire actually started on the topmost apartment floor. It was a faulty air conditioning unit. The condenser, the air conditioning condenser, or the compressor, had a short and it caught fire. It was on the topmost floor, but the entire building was burnt to crisp all the way down to the ground floor. Again, they believed it was the same situation. The compressor caught fire, it ignited the cladding on the topmost floor. Say that, oh, fire will really burn upwards, right? But no, this fire took down the entire building, it burned downwards. It was literally like you hold a piece of paper, you light up the top corner, the paper will not extinguish, right? The fire will actually burn its way down. Yeah? So the entire cladding. So the common element here is the cladding. While the building inside is compartmented, everything is fine, but the cladding outside is the element that spread the fire. So fast forward to today, or rather fast forward to August 2021. Bomba decided that we cannot wait. Now we have to impose this new legislation immediately, so that all buildings fall within this. So in August 2021, Bomba issued a permanent directive for the use of external wall cladding systems. Essentially what we did was, we already have the provisions in the UBBL. At the time for the use of external wall cladding, what we say is that anything above 80 meters, it has to be non-combustible or Class O. Right, so now, in this case, with the introduction, with a new understanding of BS 8414, we introduce these new elements. So anything above 80 meters in height, we need to subject this to a full-scale BS 8414 test. Now, that is what we have to do. And for everything else below 80 meters, any materials you use must be specified to a Class O standard. And Class O meaning complying to BS 476, right? So the new one just overrides the previous 1984 provision, and basically all external cladding now will have to be Class O or non-combustible. And if it's above 80 meters in height, you're now subjected to the provision of the full-scale testing on BS 8414. So that's the good thing about prescriptive codes. Now, after a few years, you just comply with the prescriptive codes. We need not really fully understand why the code's written that way and what exactly the prescriptive code means. Because it's deemed to comply, it just specifies something, oh, I've used it since day one and I don't seem to have any problems with it, and you continue to use it. So it becomes a norm, but without fully understanding what it is. So now that we got BS 8414, a lot of questions are coming back again. Okay, so I'm going to get my building to 17.8 meters. You're deliberately reducing it by 200 mm just so that you will not be subjected to 8414. But then, oh my goodness, what is Class O? I still have to sign on it, So, okay, I'll have to go through this with you, just a recap exactly what do you mean by Class O. I'll show you a video. This is, okay, Class O primarily refers to the BS 476 series of tests. Okay, this one is 476 part 6. It's a very, very short video, terribly boring because you will not have an idea what they're showing. I didn't. I looked at it and said, what in the world is this? Okay, so very quickly. This is a test lab showing
the BS 476 Part 6 test equipment was developed for the UK construction industry, but is also used by other industries today. We're comparing the performance of our test material against the performance of a non-combustible board. We take the specimen and clamp it into the test rig, and then we expose it to both direct flame and a radiant heat source. We are taking the temperature measurements in the chimney of the test equipment. By limiting the heat released from materials, we're allowing building occupants more time to escape from a fire.
Okay, so that's 476 part 6. It's called a fire propagation test. It's, just now what you saw was the material being placed in this little frame. The flame is subjected to the surface of the material only. It's to one surface of the material. And the fire propagation test will then, they will have a sample, they will have a base material, a non-combustible, known non-combustible base material as a reference. And what they're doing is that they'll be measuring the heat propagation, the release of the smoke, and a few other criteria, and they put it into a formula. I have no idea what the formula is. Thank goodness we are architects, we don't have to get down to those boring stuff. Generally, the formulas will then come up with the index, with a propagation index. And the idea is that for you to pass BS 476 Part 6, you have to have an index of a certain number and below. Right? So this is this is Part 6. So the next video. Oh, okay. Right, so the next test, now this one is a little bit more visible for us. This is the BS 476 Part 7 surface spread of flame test. Now when we specify surface spread of flame, we go for class 1, class 2, class 3, right? Whenever we do all that. So this is specifically for that purpose. It's BS 476 Part 7 surface of spread flame test.
The BS 476 Part 7 test equipment that we see here has a long history in the UK. It was developed for the construction industry, but it's since been adopted for other applications, such as the UK defence industry and train projects. We use the test to assess the spread of flame across the surface of a specimen. The operator will take visual observations, looking at how far the flames have spread along the reference line, which is drawn onto the test specimen. Only flaming on this reference line counts towards classification. The further the flames spread, the worse the test result.
Right, okay, so this is a little bit more visible, I think a little bit more physical. There are all these markings here. These markings are all standardized markings in terms of to measure the spread of the flame. That little point there is where the ignition source of fire is. This panel here is to give it a radiant heat onto the surface. This is the material on the test. What it does is that it's just measuring the rate of the spread of the flame. You start off with the ignition over here with this radiant heat heating up the surface. You just measure over a predestinated time frame how far are the flames spreading. The faster it spreads, the bigger the classification number. The lowest one is 1. So I think this is 1, this is 2, this is 3. Yep, that's correct now. So if the flame spreads to here within the given time, it is below, and ending below that is called class 1, class 2, class 3. And if it goes out of the sample, it's a total failure. Class 1, the whole thing is burnt. So then you're asking me now, where is the test for class O? There isn't a test for class O actually. Class O is actually a specification, and in particular in the UBPL, this is how they describe class O. These are verbatim from the UBPL. I didn't create this one. A UBPL 204, classification or restriction of flames over surface wall and ceiling. A. Any reference to a surface being class O shall be construed as a requirement that, number 1, the material of which the wall or ceiling is constructed shall be non-combustible. That's it. If you have the material as non-combustible, oh, by the way, the test for non-combustible is BS 476 Part 4. Right? That material, non-combustible. It passes that, it's declared non-combustible. It's either yes or no, it's either combustible or non-combustible. It's a very fine line, nothing in between. So if it's non-combustible, that's it. A lot of the materials we have is really specified in the UBPL schedules. as deemed to comply, non-combustible. For example, we know clay bricks, non-combustible. Terracotta tiles, non-combustible. Clay tiles, non-combustible. Cement board, non-combustible. Done. Yeah? It is just deemed to comply, don't even have to think about it. But however, any materials that are not already in the schedules, okay, this is how you define class O. The surface material or bonded throughout the substrate, the surface material in conjunction with the substrate, shall, when tested in accordance to BS 476 Part 6 and Part 7, shall have an index of performance not exceeding 6. Okay, what does that mean? Right, so first, if it's a non-combustible material, it's deemed to comply, deemed to be class O. If it's not, that material will have been subjected to both 476 Part 6 and Part 7. And Class O, once it complies to both Part 6 and Part 7, it shall be regarded as Class O. So Class O shall be regarded as of a higher class than Class 1, Class 2, Class 3, or Class 4. Right, so this description of Class O is a prescription in the UBBL. Right, and this is all it means. So how does it apply to us? Okay, so Part 7, Class 1 means within 1.5 minutes, the flames do not spread beyond 165 millimeters. That's the first marker. And Class 2, Class 3, Class 4, etc., etc. Yeah? And then, what about Part 6? So this is how it works. First, for the material to be Class O, it has to achieve a Class 1 fire rating from BS 476 Part 7. That means the lowest category. The flames does not exceed 165 millimeters in 1.5 minutes. So that's the first one. The second one is that it must achieve an index of I1, i.e. less than 6 from BS 476 Part 6 fire propagation. And we will not know how they come up with the index because I won't go through the formula. Right? When they do the test result will say what is the index. So if you have a material that it says it's Class O, do read the results and decide how they determine that it's Class O, because it's not a single test. Right? So that's what we need to do. And having seen the testing method, we know that the test is actually the flame on the surface. So by having a flame on the surface, it will not be able to test what's the effects of the fire if the fire is on the other layers of the component. Right? So that's why we had a big problem before. Even before Grenfell Tower, we actually had some problems. We had a lot of problems with composite materials, composite aluminum cladding, where they use where the interior infill is bituminous material, largely combustible, and a lot of those materials actually passes Class O, because when you send it for the Part 6 testing, they're testing the aluminum, the surface. The test is so simple that you can see the test sample is very small and the fire load is actually extremely small. It's just 1 point flame. It will not have been strong enough to ignite the sandwich material, the composite material that's inside. And likewise for Part 7, again, it's just on the surface. Right? So if the surface burns, the flames are not strong enough to have ignited the composite material. So that's why even up to today, if someone says Class O on aluminum composite panels, I will treat it with great caution. Right? Just for your own sake, insist that I want to see mineral core. And one of the easiest ways to determine whether it's a bituminous core or a mineral core is that you just look at the color of the infill. If the color of the infill is very, very light grayish to whitish, then it's probably mineral core. I say probably because people can do a lot of things nowadays. But if it is black, it is almost definitely combustible. Right? It's almost definitely not a mineral core. So yeah, do that. Yeah. So good. So we covered class O. So now what is BS 8414? BS 8414 is a test system for a complete system. It's no longer a material test. As we can see, BS 476, part 6, part 7, we are just testing the surface of a material. It is not a test of a composition of a material. BS 8474, on the other hand, is a testing of an entire assembly of the entire wall cladding system. That means you literally have to build this wall the way you intend to construct it, and you subject it to the test. Now, then I get a lot of questions, and they say that, okay, so do I have to test my windows? Aluminum cladding, glazing, oh my goodness, I have to bring all of that for testing, I have to construct the entire wall. No, see, BS 8414, as we have illustrated on the first 3 slides, if your building is compartmented on sides, on the separating wall, on the sides and on the inside, you're fully compartmented, fire, you will have to expect that there are windows on your external walls, that there are openings on your external walls, right? And the problem with the cladding was that the fire broke out from inside the building, from a refrigerator, and it went out of the window, and the cladding caught fire, right? So 8414 is to test that situation. It is not to test the fire rating of your window, because the window is expected to be a non-protected area. And that's where the 6th schedule comes in also, right? What's the proportion of, what's the percentage of non-protected areas versus protected areas of your external wall, okay? So that is the 6th schedule. That's another story for another day. So on the non-protected areas, those are windows that you need. They are windows that you need for ventilation, even air louvers, ventilation grills or whatever. Areas of the wall that is non-protected. Right, so BS 8414 testing, no way can it actually configure a test for you to test that. That would be the 6th schedule. That's why 6th schedule is also very important. But here, so the test method is purely to test on the cladding. What is the effect of the cladding in terms of the spread of flames when a fire breaks out from an unprotected opening? Right? That is the sole reference for this test. The performance of a cladding for a situation where a fire breaks out from an unprotected opening. Right? That's very, very important. That's very, very important. Just understand that element. So BS 8414 test method developed. They are to evaluate whether a cladding system subject to a fire breaking out of an opening, such as a window in an external wall, will result in excessive fire spread outside of the building. And it is entirely different from BS 476, which only conducts the flame spread of the surface of the material. It documents a fire propagation in response to a complete cladding system. And it does not cover, naturally, it does not cover the performance of doors, windows, balconies, or anything else that will constitute as a non-protected opening. Right? Okay, great. Now, BS 8414 is divided into 2 parts. That's part 1 and part 2. Part 1, that's part 1. Part 1 is that number there, 8474-1. So that's part 1. Part 1 is for a system which is supported by a masonry substrate. Whereas part 2 is for a system that's supported by a structural steel frame. So now, what exactly is this definition? When they say supported by masonry substrate, what it means is that this cladding or this system that you're trying to test forms an external cladding to your wall, which is already a protected wall surface. So under the 6th schedule again, when you design according to the 6th schedule, when you specify a masonry wall or the wall of any other construction that is solid, uniform throughout, and that area is already a protected area, 8414 Part 1 tests the cladding system that you apply to the surface of the wall, like in the case of Grenfell. 8414 Part 2 is for a system that's supported by a structural steel frame. What it really means is that 8414 Part 2 is for the testing of when your cladding system is the wall itself. So you have a structural steel frame, or any frame for that matter, and you have this wall paneling coming in. And that is the wall itself. So there's no protected element behind that wall. Right? This cladding is the wall itself. Right? So this is the definition. If you're designing a system where you have a cladding, you go for Part 1. If you're designing a wall system, a unitized wall system, or whatever it is that actually forms the wall itself, again, other than the window, other than a non-protected opening, then you go for Part 2. Okay, this is the criteria. For the testing of BS 8414, it goes on to 6 criteria. The first 5 criteria is common. First, it measures the external flame spread. Second, it measures the internal flame spread. Third, there's a visible flame criteria, where you just look at the flames, and there's a criteria there. There's a mechanical performance test on the structural integrity of the system. There's also a measurement of the burning debris and pool fires. Things are going to fall off the cladding as it burns. How much of it will be falling off, right? Then the 6th element will be the system burn through. And system burn through only applies to 8414 Part 2 testing. The first 5 criteria applies to both Parts 1 and Part 2, whereas additional requirement of system burn through only applies for Part 2 test. Okay, I'll just show you a very quick video, promotional video from Sirim. This is what the rig looks like. That is the test sample. It's all within a single dimension. This is the crib, the specification of the crib, the specific timber species, and the amount of weight, how many kilograms of timber and all that is also specified. It has to be consistent. They specified a pine wood from Europe, so Syrian do have to import the exact same pine wood, the exact same species. We can't use chengao to light up the fire, because test results will be different. We should come up with Malaysian standards, like use chengao as the firewood. This test is over a period of time of 30 minutes, and then all the 5 or 6 criteria that we mentioned earlier will be measured and observed throughout the test. Okay, next. Okay, now I'll show you the difference between Part 1. Just now that the Syrian video was on Part 1, you can see that there's a masonry wall behind and this cladding is just on the front. So this is a test of a Part 2 test. So you can see the Part 2 test, the rig is just a steel frame. So the rig itself is not the thing on test. I think that we have to make that very, very clear. The thing on test is everything else that you attach to the rig, because that is your system. So there's no masonry wall behind. This wall is the wall itself. So if I do the leaping out, okay, so this is the test. Now this is Part 2. It's okay. I don't know if you passed. Then the the criteria of the burning debris will be this. This is the fixed dimensions of all samples. For consistency, you must do it in the exact dimensions and fit it within there. The creep is of the exact size. And for burning debris, there is this creep zone here. All debris that falls must fall within the creep zone. Things that fall outside the creep zone, anything that falls outside the creep zone is limited to no more than 900 millimeters in dimension, and it cannot exceed 200 grams of weight. Yeah, the idea is that for the materials that fall outside the creep zone, if it's 200 grams is about the weight of a small packet of cheap small biscuits. Right? So if something like that falls at you from a height of 40 meters, presumably it wouldn't kill you. So 200 grams was the limit that they put. Otherwise, everything else has to fall within the creep zone. And this is also tying back with the minimum age of the fire appliance access, a minimum 2 meters. So it is actually meant for this purpose, right, for falling debris. Okay, so the difference between A414 Part 1 and Part 2, the setup for Part 1 will be this. You'll be given a full masonry wall, and that would be the combustion chamber. It's concrete and it's got this little latch, this little recessed latch over here. And the crib is predetermined in terms of the fire load. So the idea is that this one simulates the top window sill or the opening sill of the unprotected opening. So a fire, when it leaps up from here, if you don't have a cladding, the building is already safe, yeah? Because if you say, I'm going to test my cladding, where's your cladding? Oh, I have no cladding. Okay. So you light up this fire, you burn, nothing happens because that's it, the fire will not go anywhere, there's nothing to burn. Whereas for Part 2, this is just a steel structural frame, that's not the system on the test. So the cladding that you put in the front would be, yes, the opening, there's opening over here, when it burns out there, it's burning your wall, which is your system. What happens to that wall? So the components that you bring in, you are responsible. When I say you, I mean we are the ones who are initiating the test anyway, I suppose. The manufacturers, the building suppliers, and all, they'll be designing this system. They'll have to assemble this system to represent what is it that we want to put on our buildings, and we have to deliver it to this test rig. And everything that you assemble, everything that you bring to be assembled onto this test rig will be part of your system. So if you have no intention of having that element on your wall, please don't put it in the sample. Okay, because this is called a homologation test. In other words, when you pass this one, you have to build that wall that you are going to build with all the same components that you put onto this test rig. If you have a variation on that component, okay, they'll say that, oh sorry, you're not building it in accordance to what was approved. So you have to be very, very careful. So they're going to give you a masonry wall, and you have to build your cladding. So the cladding will involve everything, the box that you fit in, the angles, the brackets, everything it is that you have to do. Most times we only look at the external skin. Oh, I want this paneling, I want that. But no, you're responsible now for every single thing between the masonry wall and the paneling. If it's a structural frame, similarly, you're also responsible for everything that you're going to hang on to the structural steel frame for the integrity of your panels. The framing, the insulation if you want. The slight difference is that for Part 2, you also have another element that's on test, and that is the inner lining. Okay. Before I go to that, very, very important, do not forget this detail. That detail is the most crucial detail because that is the detail that you have to apply to to the top of every opening. Because this is what the test is. The test is saying we are testing if the fire is breaking out from an unprotected opening, leaping up to the flames. So you must design this detail. The standards does not tell you how to do it. The standards does not give you any prescription. It is entirely us. We have to design it, and when the components go to the site, that is the key element. And after the test, when you get your approval, then the certification, you must have that same detail installed on the window sill or the sill of every unprotected opening, because that's the most crucial element. So that will be a cladding system. And for part 2, you have the additional element identified as the internal surface. A lot of times there's a bit of issue over here. People are saying that, I've gone through quite a few projects on this. Some people are saying, oh no, we on the inner wall, we actually want another layer of a partition. Or say if you're doing a clean room installation, they say, oh, the inner wall is actually the insulated panel and all that. Are you sure? Do you actually want to do that? Because if you're declaring that the whole system, the integrity of the whole system depends also on the inner wall, then you have to bring the inner wall for the test. So do you actually want to do that? The whole idea is that you will want to have the system to be as minimum as possible so that it survives the test having the fewest possible components, and that becomes the system. Then when you apply onto the actual building, you can do any other internal wall linings and all that for aesthetic purposes, for interior design purposes, or for functionality purposes, right? But the panel itself stays, yeah? So I would suggest you cannot include any other elements that's behind the steel frame as part of your system. If you put it there, then you're stuck. That element will have to be part of the system. Okay, so after having set up this test, then you start out the flame. So of course it measures all the flame spread, the internal temperatures of within the core, within the cavity, if you have the cavity. If you fill it up with insulation, if you fill it up with rock wool, very good. If you fill it up with what's that material? If you fill it up with bitumen or whatever, then good luck to you. All right. If you fill it up with polystyrene, very good luck to you. So that is really what it tests. So all it's saying is that a fire breaks out from an unprotected opening. You would not want the flames to go in here. If the flames actually do get into the cavity, it will not exceed that particular flame spread or the temperature. And the outside similarly, all the 6 criteria that I mentioned earlier. Then for part 2, similar criteria with one additional one, which is the 6th element system burn through. So this is where you have to be very, very careful what you define as the inner surface. Yeah. If you come up with a structural steel frame without the inner surface, we'll just ensure that the flames do not ever get onto the inside. That is all. Okay, this is a quick example. This is not a test itself, it's more of a demonstration of various infill materials, extended polyurethane, rock wool, PIR. So as I started a fire, the fire is just burning. I just passed around it. So as you see, the rock wool is just burning, but it doesn't seem to be contributing to any combustion on the sandwich panel inside. PIR, you can see smoke is spewing out from within the panels already. Because the PIR is actually on fire, it's really burning. The rock wool is very stable. Extended polyurethane, this one, it appears to be stable for now. Let's look at what happens in the field. So PIR is a goner, total goner. The flames have spread beyond the grip zone already, it's spread beyond up there, and definitely on the inside totally burned. The 2 rock wool materials are still holding on pretty well. expanded polyurethane, you say, hey, pretty good one, huh? It seems to be holding up quite well, but not exactly. Once you catch it fire, that's it, it's gone, the whole thing is gone. And rock wool, you say, is still fairly stable. PRR, they have to put it up with it because it's so this is what I mean. It's an entire system. It's not just a surface. And be very, very careful with every single component that you build. Alright, very quick study. I did this building. This building was completed during COVID, but the plans were approved and we went in way before Bomba issued the August 2021 directive. Because I knew it was coming, so we just took the initiative to use it as a test case in terms of talking with Bomba and all that. So this is an industrial facility down in the state down south, and these were detailing. We had two kinds of walls over there. We got both part 1 and part 2. The part 1 is this one, where we've generally got the reinforced concrete structures. We've got the masonry frames, AAC blockwork, and we have these composite panels. Now these composite panels have got a very deep cavity, say 900. The intention of this is that we are creating the very deep set window appearance. And also because we did need the cavity for a lot of other purposes and tying in with the other structural members. So this is the detail we came up with. So of course we did not send in the building material, the building test with a 900 cavity. We did it. On the test rig, we can't do a 900 cavity. If we do a 900 cavity, we cannot even turn around the corner. Say the corner is only 1.2 meters. So if we do a 900 cavity, we turn around the corner 900. It's like, hang on a second, the test rig it doesn't even fit in the test rig. So how did we? How could we even test something like that? The intention is that all this testing and all is not supposed to restrict your creativity. It's not supposed to. If we do everything just for the purposes of passing the test, all our buildings will again end up being square boxes. It's like, well, always said, if you design the building 100% in accordance with the prescriptions of UPPL, we're all ending up with square boxes with tiny windows. So what we did was we used the references or the inferences as to what's the element of the test. So we do not have any material within the cavity. So there's no insulation, there's no rock wool, there's no infill material. So it is a cavity, it is purely air cavity. So what we'll be measuring will be purely the temperature in there using the air cavity. Right, so we determined that a larger air cavity will not adversely impact the test results. And secondly, in terms of the flame spread within the cavity, yes, we did define all of these flame stops, but yes, so this is a cavity, this is the 900 cavity. The fire stops that we specified was of a very specific material and a very specific dimension. So we cannot possibly increase the dimension of fire stop. Why? Because this fire stop is pliable material. I can't just stack on the fire stop and tape it with masking tape to create that extra cavity. So what we did was we used concrete fins. We physically extended concrete fins up there so that that element, that dimension is equivalent, is the same dimension as what we sent for the test. Right, so this become regarded as part of the non-combustible physical building structure element. Right? And the air cavity, we said that, okay, this air cavity, I got no material inside. So the air cavity, by having a greater cavity, in fact, improves on the temperature reading of the flames. Right, so these were the things that we were exploring in those days. Because we were early, so it helped us a little bit that we were just using this as a test case ourselves. With the vertical fire stops as well, exactly the same concept. So effectively what we created was, behind this very deep cavity, we created a four-sided concrete fin to contain to restrict the volume of the cavity. So that is how it turned out eventually when we put it in. You can see that these are the elements, the concrete elements where we have the fire stop. I don't think the fire stop is installed yet. And the other one is part two. Part two, because we have all these walls which are unitized wall panels. They are meant to be removed later when we do the extensions of the building. So this unitized panel went for the part two testing. Right, of course, this unitized panel actually included the windows, but of course we do not send the window panel back into the testing. The testing was just on the assembly of this sandwich composite material, and this one consists of frames, aluminium, rock wool insulation, and all that. So this one went for part two testing. Right, this is how it turned out. Each of the frames is actually that size. Actually, the full height, which includes the windows, like this. Okay, so generally that was our adventure during the days while we are doing the adopting the BSA 414 testing. And well, I hope that today I've managed to give you a little bit more information to assist you in your design. Just remember that we are all architects, so do not, I've always said this many times, do not ever start designing your buildings by referring to the Uniform Building Bylaws. It doesn't work that way. We end up with square boxes and they will look exactly the same. All our buildings will be exactly the same, like in the communist era. One standard template, that's it, deemed to comply. Use your creativity by all means, but then after that, understand the bylaws, what exactly are the implications, what exactly are the purpose of each of the prescriptions and the method of testing. Apply correctly, then we will have very beautiful buildings and they're all very safe at the same time. And thank you very much for your time. Thank you.
Welcome back. Good afternoon for those who joined us late. I'm going to start off the second part of the sharing this morning. Earlier on, the first part, I think Architect Chong has done a very insightful sharing of 8414 about Class O, when do you apply Class O, and when do you need to do 8414. So, on my part, I'll be sharing with you the tests that we have gone through. So you know the compliance, and then deep down when you do the test, what do you look up for, and more like try to walk you through the test, all right? How many of you have actually attended or witnessed the 8414 test? Can I see show of hands? Well, except for, of course, the expert architect Chong, I don't see any hand being raised. Yeah, so it's something that is not new, but still not many have gone through the experience. So I'll be sharing the actual test that we have done. And next topic is the legal consequence when external cladding catches fire. And lastly, I'd like to, maybe it's time to be innovative. Like Architect Chong said, don't be square blocks, right? Time to innovate. This is the opportunity. Okay, this project, Setia City Mall, is the biggest shopping mall in Shah Alam. There are two, there's an existing mall and then there was an extension. So the timing was such when they construct this, right? The implementation of 8414 came in, and they were trying to get a waiver actually. The developer is Setia JV Lendlease, all right? Lendlease being a foreign big-time investors, they try to also arm-wrest Bomba to get an exemption, but they couldn't do it, okay? So good for Bomba because safety cannot be compromised. So we are the first to use a test rig other than for show during the launching, which I attended. True test were the first. So just to share, so there are two parts to this mall. Existing is a masonry wall. Then extension being Lendlease Australia, they use drywall system, right? So there's a drywall extension next to a masonry wall existing. Then eventually the full mall is cladded using this colour-bond speed deck. So it's the first shopping mall that is cladded using a corrugated or trapezoidal profile instead of the ACP. So you can see close up, right? Again, the only thing is it's more than 18 meters, right? They cannot depress the height. It's an existing mall. So let me take you through the experience we had on this mall. So can you imagine for this project, Bomba wanted 3 tests to be conducted, not 1, 3. You must be wondering why 3, okay? Later on, I will share this one, the test number 1, which is part 2. Just to refresh, there's a part 1 and part 2. Part 1 over masonry wall, part 2 over a structure. So this is the extension part, which is the drywall system. Hence, there is no masonry wall. It falls under part 2. Then, of course, naturally, under masonry wall, you do another test under part 1. Okay, that's fair, that's natural, because it's part 1, part 2. But under part 1, 2 tests. This to give you an insight how strict, I use the word, how strict Bomba is, right? Don't think you can try and convince them. Maybe with knowledge like architecture, they can manage better. Otherwise, you go in, they give the prescription like a doctor, you just take it and then that's it, right? No argument. So why 2 tests? This, you can see, was outcome of their, what do you call this, launching. They have a ACP test. So this one, you can see the subframe, right? These are the framing, the main frame to support the cladding. So the cladding is trapezoidal going vertical, so the framing is horizontal, natural, right? But then on certain area, the toilets area and all, you cannot find a concrete structure to mount it in such a way that you want it. So the main frame is vertical. Vertical. The white color one is the main frame. The main structure is vertical. What you see horizontal is a subframe, because we cannot mount that cladding onto a vertical mullions. You need the transom. So we add on the transom. But because your main frame is vertical, it's different from the other one. So the fire spread behavior would be different, right? So Bomba says you need to do another test for this assembly. So 3 tests conducted. This is we shared the test report. So on the top is applicant. Who is this guy? Is a main con. That was the first project, and I can tell you I was stressed. Architect specified my product and say, hey, Mr. Lau, is your baby, your product. You have to pay for the test. 3 tests, 200 over 1,000. I can't even make the profit supplying to that project. I tell you, it was stressful. So it went on and on, then the MinCon and so forth. Anyway, to cut the long story short, the MinCon became the party for the applicant. Why I shared applicant? Applicant pay for the test. When you apply, it's online, the applicant, you have to pay, then you get your queue number. I got a project recently, the MinCon design build, said, hey, Mr. Lau, while we decide, you go and book a slot. I said, no booking. Booking means you got to come out with full set of drawing submission online and pay your fees, then you get your number. So you cannot jump. You got to get your system design firm up first. So it's stated very clearly, this is I'm sharing with you the part 2 test. So the product is clearly specified. Hey, look at the date. Talking about 2021 enforcement. We already conduct the test in 2019, so the enforcement is somehow lagging. 2019 is now 5 years. At that time, we had a lot of conversation in Bomba, and then I also asked, is this going to be implemented retrospectively, because so many existing buildings? And the answer is yes, 3 years. Today is 5 years. I don't see any change of existing cladding taking place. You know, so just to share, supposed to be 3 years retrospective, but of course the official is 2021. So final, I think also expired 3 years. So this is the kind of details or shop drawings that you need to submit. So it's not as simple as putting an application and then you get a queue. So this is a combustion chamber. So like what architect Chong says, this is crucial. And everybody was stressed out because nobody have any experience the first time. So to play safe the construction in progress, but it failed. So they put on a fire stop, a rock wool, just in case, just in case. So we did the first test with the rock wool. So that's the cross-sectional drawing. So here in the report, everything is captured. The cavity depth. Okay, cavity act like a chimney to propagate the fire. So any test done, they will record your cavity, and you cannot come forth next time. Hey, Swisma metal cladding, this one test everything the same. Hey, but friend, your cavity now is 500. No, retest, or even 300, retest. The question we ask is, can we do a range, let's say 150 to 500, anything in between, dim pass? There's no firm answer. No firm answer, right? So it's still due I think architect has to work more to convince them to be more rational. So the fire stop is captured in the specs, like what architect Lee Xiong say. Whatever you do in the system, you must apply. You don't go and cleverly add a lot of fire stop and then pass hooray, and then you go and take that out in your construction. If they do visit your site, then you have breached your approval. Okay, this is a full-scale test. So it's 8 meters in height, 2.6, and they have a wing side 1.5 meters. Everything is specified. I would say I have to respect that they have been fair, right? Even the firewood, you have to import, no chengal. And the criteria later, when I take you through, is actually fair for all assessment. So this is a test rig for part 2. That is a structure provided by Sirim in the test. So we have to get our contractor in to assemble the structure. So these are the actual structure that you construct on site. Down to the boat size, number of boats, your member size, actual construction drawing duplicated and constructed on the test rig. So that's why when the contractor say go do booking, I say where is your structural construction detail? We help you to develop the shop drawings, not finalize, then nothing to move forward. You have to finalize your steel structure. So this is a dry wall, okay? So they have insulation. So everything, this is extracted from the test report. They captured everything, right? They didn't just do a written report. It's full of evidence with photograph. So what you use, gypsum board, that's the inner wall. External wall, they use, what they call this, cement board. Inside they use gypsum, in between they have rock wool. So every detail is documented. So that's what I say, first test a bit kiasi lah, what it failed. So we put that insulation there on top of the chamber because that's the best defense for any temperature rise or fire going through the chimney. So that's it. Then we install the perimeter flashings, and this is a fully assembled for test the system. Then this is after 10 minutes they have a photograph. 20 minutes after they have a lot of photographs taken. So this is a video. What you saw earlier was a lot of ACP. in the test for ACP is very different from this. Why? Why? You see that magic moment when you test ACP, now you see it, now you don't, you get a big hole. Why do you think that happened in ACP? Not in steel. Okay. The reason is, later I'll come to you, think about it. What is the reason why there is a big hole there? So it all based on criteria, right? But part 1 masonry wall 5 criteria, they added the 6 burn through for part 2. So I'm sharing part 2 so that you get the comprehensive criteria assessed. So this is some information, the dimension, 2.5 meter above the combustion chamber, they have thermocouple. Thermocouple punch through your test, inside, outside, that's where they measure temperature. Then level 2, another 2.5 meters, 5 meter above that. So remember the level 1, level 2. So level 2 is the one that is most kacau one. This one, they were thermocouple. It measure a temperature of 600 and beyond for more than 30 seconds. After 15 minutes from start time, you can go back. Fail. Fail. Most tests ACP fail earlier because of this. Right? Fail. This is the first and second criteria already failed. Bungkus. No need to go further for 1 hour. Okay, then, okay, here the report says start temperature, ambience temperature, even the wind velocity is like fair, calm, no wind. And then you see the word start time, 8 minutes, 12 seconds after ignition. So, to be fair, a lot of people think set fire, then you start the timing. No, it's not true. Depends on, some fires start slower, some faster. How much fuel you add. So they are fair, there's start time. The start time is when the level 1 thermocouple registered 100 degrees Celsius. That's where the time starts to tick. And for the next 15 minutes from start time, that's where they record your level 2 temperature. If it hits beyond 600, bye-bye. That's it. Alright? So they have a thermograph. So you can see the temperature over time. And at level 1, it can go up to 900, as high as 900. So level 2, the test captured about 500. So it must be less than 600. So we pass. All this cavity area, the temperature is lower. So the report says pass. That's 1 and 2. So we are through. Next, 5 criteria to satisfy. Then the visible flaming, right? Visible flaming. So the flame cannot exit the confine of the test rig vertically or laterally. So then they are fair. They always say that it has to be continuous visible fire for 60 seconds, not flicker. Flicker is not considered fail. Actually, I don't know how they can monitor unless you go back in time, 60 seconds, If you are not using combustible material, usually it's not an issue. Okay, the report says pass. Okay, next, the mechanical performance. So the mechanical performance, like what Architect Chong said, they have a collapse zone, 1.2 by 2.4 meter. Anything falls onto the collapse zone, nothing to worry, okay? You pass. It must be outside the collapse zone. And they also define, right? So there's something, if it falls, it hits or what, it's not fatal. So there is a length, 500 mm length, 200 gram. After that, they really measure and weigh. Fortunately for us, there's no such measurement needed because it didn't fall out, okay, nothing fell. All right, that's what they say. And I think because of this mechanical performance, correct me if I'm wrong, Architect Chong, I've spoken to a lot of people. Typically for ACP cladding, conventionally is always aluminum subframe, am I right? Right, you use aluminum subframe. But today, I think they are changing aluminum subframe to steel, which to me is not a good solution. Because steel, when you drill holes, even you hot dip galvanize, the swath, you will rust, and the rust stain can create very bad visual impact. But because of this test, they dare not use aluminum. Now that brings to point my first question. Why ACP you see a big hole? The reason is at level 1, temperature can go up to 900. So what's the melting point of aluminum? Anyone knows? 650 or 660 degrees Celsius. That's melting point of aluminum. So at level 1, when it's 900, that's why you can see it's really gone. Evaporated, melted, whatever, right? So when it melts, maybe there's a pools of fire. Huh? So that's why the subframe also might not be able to withstand that temperature. So you change to steel. Not a good solution, but because of the test, I think to be safe, you use steel. So any material you use that has got low melting point, below 900 degrees Celsius, it will melt or it will just disappear. So just bear in mind. But it doesn't mean that it melts, it fails, right? Otherwise ACP will run out of business. So you still go back to the criteria, right? If your temperature at level 2 does not exceed 600, and how to make it work? Fire stop all over the place, right? Horizontally, vertically. That's where you have to, what you have to do to pass. But whatever you do, make sure you implement on site, that's all. So the cost of doing ACP is very different now. You've got a lot of additional fire stop, and it's not cheap. If you use the real type of fire seal like site rise or whatever. So that's the major departure in the method of installation. And test 4, we pass, nothing falls out. Then the burning, debris, and pool fires. So this one, if it's within collapse zone, like you can see how heavy it is still okay. But outside, again, not flicker, sustain for 60 seconds. Then you can go back. Okay, this is what the pools of fires is about. Especially when you use flammable stuff, very heavy pools of fires. Bomba fire brigade cannot even get near. So I think it's for that rescue reasons this came in. So there's no pools of fires falling outside the collapse zone, or hardly any pools of fires for this. So the 6 criteria for part 2 is burn through. So ours is a dry wall. So despite that, the fire cannot penetrate through, because then the fire propagation inside defeats the purpose. And they also prescribe 0.5 meter and above. And it has to be 60 seconds. And again, 15 minutes of start time. It's not whole duration. But by the time you pass the 15 minutes, that's how it is. After a while, they put out the fire already. They put out the fire. It's not that the fire burned until for an hour. So we pass, and this is a video of how, accelerated pace. So that is a typical pattern, the triangular shaped fire. So this is the outcome after the fire has been put out. So you can see the same triangle. The only difference is because steel melts at 1005, so it didn't melt away. And when we dismantle, you see that the cement board was scorched. There was also a lot of stress whether the cement board can withstand the fire, right? So this is what happened to the rock pool after dismantle. It's supported by the flashing. That is a key component to prevent the fire spread above your window. So it's still very much intact. And before and after testing, so the pain, we were also trying to imagine what could happen. We were so worried about the screw popping out, all this concern, because when this thing happens, it failed. So This was a real challenge, but anyway, everything went fine. And after the first test, Landlease, they have got very big engineering department in Australia. They do a simulation. They say it's 500 degrees Celsius only, still quite safe. So do we still continue to use fire stop? And the answer, they make a bold decision. We do away. They did away, yes, for the part one, both the tests, and it passed. It passed. So that one is benefit from their own engineering department. Otherwise, the same fire stop, I'm sure you will have to put in place, right? So just now we talk about Grenfell. Grenfell was a disaster, 72 life was lost. And then I think what triggered Malaysia was the KWSP, right? The Federal Highway. That one already, when that happened, Bomba tapi tahan ready. He says it's time to act. So, but then when we see those projects or those unfortunate fire that happen in overseas, right, in Canada or wherever, in London, somehow it doesn't sink in. It's like you watch another Hollywood movie. I'm sorry, not trying to be. You just see it doesn't have a real impact on you. Yeah, it's good to be safe, good to be safe, right? It's just like don't drink and drive. It's good to be safe until one day something happens. So it's always good to have something to trigger ourselves that we really have to be responsible. So I'm sharing the La Crosse Tower. You can always check it out more detail in the internet. So La Crosse Tower in Australia happened in 2017. So this is a fire. Okay, you can see 229, the fire. This is a simulation, 229, then it spread. By 239, within 10 minutes, it's already spread up to the top. 10 minutes, that fast. Very super fast. It's not like taking an hour. By the time Bomba get a call and react, the fire already spread up. So this fire is caused by a smoker. Okay, smoker be more responsible. Unextinguished cigarette butts at the balcony. Caught fire. That's it. Whole building got burned. So what happened in this case, why I shared is, of course, the Grenfell, they finally concluded the public inquiry took forever, right? This Professor Bisbee, right? He's the chairman. But in Australia, it was fast. I think Aussie moved faster than the Englishman. So here, they took the case to court. Okay, the apartment tower residents took the case to court because, hey, my apartment got burned. So went to court, and then the court make a conclusion, awarded millions in the fire. So this triggered a big hoo-ha there in the construction industry in Australia. Oh, come on, when that is a payment involved, everybody open their eyes. So here the judge finds architect proportionally liable for La Crosse fire damages. I just share a bit of story about this, it can be interesting. Because it will happen in any of our projects. So what happened is, like what architect Sean says, you got to be careful. You look at it, black color is definitely combustible. Don't bullshit. That is going to be a very safe cladding. So here, product, they got different specs, right? Non-combustible core and combustible core. What was specified by the architect was the right stuff. It's a non-combustible core. Then during the course of construction, as usual, contractor cut costs, but in their term is value engineering. Value engineering. So they came with same, I don't want to quote the product name, very reputable one, or the most reputable one, you go and figure it out. You can see it from the internet anyway, right? So they proposed same product, but non-fire grade. So the architect approved. So when this case happened, architect was called to task, and architect said, look, we specified something that was fit for purpose, but then you approve the alternative. You say, I approve for aesthetic, for color, for aesthetic, not for change of system. Architect, the judge said, come on, don't bullshit. Right? Is your inherent responsibility as an SO. So the message is you are the SO, so you are carrying that full responsibility. The judge doesn't buy the excuse, despite having done the right specs. So what happened is, now 5.7 Aussie dollars damage was paid up. So these are the parties that contribute towards that payment. In Australia, it's a bit different. They're building surveyors, not like our quantity surveyors. They play a very important role. They also have fire engineers. Here we don't have, right? So maybe the building surveyor could be our, their buildings could be our quantity surveyor, I don't know. Fire engineer, I don't know, maybe he's a facade consultant, we have facade consultant. So anyway, these are the parties. Now, fire caused by the smoker, big culprit, right? So this is the pie chart, the percentage. I want you to take a moment and think, who's the guy paying 3%? Who's the guy paying the most? Who is most responsible? Wow. One rationale is, without the carelessness or the negligence of the smoker, everything will be okay. So this guy should be most liable, right? He caused us the fire. So do you think he should pay the 39? Anyone think he should be paying the big part? Architect, wow, see this guy very responsible. Engage him, very responsible architect. Straight away, he take ownership. Okay, so anybody take architect as the 39%? I see some hands. All these are very responsible architect, okay? Taking ownership, very good, right? But because of the structure in Australia is a bit different now, because you can see the fire engineer, building, right? So what happened is, this building surveyor is also taking a big chunk, 33%. They are like the typo, I know, right? I don't know whether, but still, again, so a bit of comfort lah, not the 39, 25%. Okay. So the most liable person is the fire engineer. The word fire implies everything, right? But then the architect say, the fire engineer take care, usually it's like that, right? You have no time to look after all these things. Unless the bylaw says, okay, now bylaw says, okay, A414, I'll do A414. Before that, class O, that's it. Fire engineer in Australia take care. But despite all that, you got building survey, you got fire engineers, still the architect is liable. The smoker, only 3%. But that is enough to make him bankrupt. Right. So, Australia is a Commonwealth country. I don't know whether we have Commonwealth or not. We are different wealth. The one that is rich is the colonizer. The one colonized never got any wealth. So, but they call us Commonwealth. So, but because we are Commonwealth, we share the same set of laws, right? So, when fire happens in Malaysia, if I'm a lawyer, easy money. No need to do a lot of digging. Just pull out this case, right? So already spell out who is liable. Now the thing is, what do you do to cause the fire only? That's all. The compliance, do you do? You don't do? That's it. Straightforward. So that much of sharing, because when I read this news, I thought, oh, it's interesting, quite an eye-opener. And more so is in Commonwealth, right? Whatever happened in France and all, well, it doesn't seem to have a big impact. Okay, so I will just share the part, because the big sharing of if 1.4 already done by architecture. Now, time to be innovative, like I say. So before this is always ACP. I don't know why, huh? Brand A, Brand B, Brand C, ACP. Every project you go is whether rectangular or whatever, your innovation is based on that. geometry. Okay, now maybe time to think out of the box. So we can actually offer the cladding solutions. Example, even this profile like this, we always see as a roofing profile, right? But in other countries, it's not really so. Say in Australia, right? They use a lot of this trapezoidal profile for their cladding system, like this, or this, depending on what kind of profile you choose to use. Or this. Or something like this. Here, we extracted and we acknowledge from the footnote where we get this from. So this is actually a corrugated aluminum. A lot of aluminum are used. But if you're masonry wall, part 1 test, okay, but part 2, don't use aluminum. Because you got no more wall, no more defense, no masonry, right? You just collapse, going through. So another project. So this is like our speed deck we use for the shopping mall, right? You can do an insulated cladding or non-insulated. And I think for the long run, if you talk about shopping mall, insulated cladding will save you energy costs. Right, it's insulated. These are just images of those kind of more industrial. But today, even industrial project, warehouse project are not exempted. So when I first came across 8414, I always thought it's commercial. Right, commercial, because like fire spread from the flashover fire spread from floor to floors. I think that's how it was developed, right? Flashover from window. That's how the whole configuration is about. Fire coming through the window and floor to floor. But you're talking about a warehouse single story. What flashover? There's no multi-story. I didn't share. I kept the launching booklet from CIRIM. In the launching booklet, it's stated very clearly. I can still remember. This test is for non-load bearing external wall cladding, right? On the building mounted 18 meter and above. Stated multi-story. Okay? But I think in the UBBL, the multi-story is taken away. And I don't mind sharing, I also use this little thing to help an architect got away with a project that is very tall but single story. He took the notes and said, look, mine is single, not multi, so I'm exempted. There's no concern about fire spreading to the next level. It's one floor. People are at the same level. And guess what? Depending on whom you talk to and how you convince, they got exempted. Alright? This is not being creative. This also sometimes there's a rational thinking. I had a conversation with architecture, and I think the more knowledge you have, the more you're able to convince for some waivers. Must be logical waivers. Just like how architect Chong shared, when he showed me that 900, right, cavity, I was like, oh my God. Then he said it's no issue. Then he has a solution. That's why he has restricted that at the floor level. Otherwise, you can't even do the test. How to pass? So that's precisely because he has the knowledge. He has the knowledge and he can present in such a way you are still compliant. That's the key point. So today, hopefully, with the presentation from architecture, you all are more bold to take on your design rather than be restricted by the cavity. But Bomba is like that. My recent project experience, I want to share. Some gentleman asked me, hey, the safest is take tested one, okay, done. But tested again, you got to copy exactly your structural steel support, size, member, bolt, everything follow like you issue LC and your DO must tally, cannot have spelling error also. So this one, the main con design build, say okay, we use this. Then budget constraint, tested was color bond material. They use plain zinc, no paint. So same profile. Actually their design was different. He said, I'm prepared to change my steel structure to follow. So I get a waivers, I get a test. But still, you cannot change, you still want zinculum and not color bond. So the architect and I went to the R&D department to see Tuan Jasni. I don't know how many of you have met him. So he just said, blah, blah, blah. He said, hey, sometimes painting also helps in the fire prevention and all that. So eventually he said, hey, why don't you go and see Sirim and get an assessment? The Sirim said he can be exempted from test then. Fine. He pushed it to Sirim. Then Sirim said, hey, this is not my baby. I follow the 8414 clause. It says any change of coating will have to be retested. I'm not the party to tell you exemption. So changing from color bond to zinculum, test. Test. So how strict, right? Support, vertical, horizontal, test. Change of cavity, test. You put insulations 40 kg, you change to 60 kg, test. Right? 50 mm, change to 40, test. 40 upgrade to 100, test. That's all, test. Okay? So, yeah, I just sharing, like, Penang is happening, but not as rampant as in central area. Multi-story warehouse, ASRS system, right? Is now a lot of such projects happening. Of course, to be a bit innovative, you can have this kind of pattern, or sinusoidal. Right? You can have insulated or single skin. This is a Mercedes-Benz. The German love corrugated. Right? Not only the German, Sir Norman Foster, when he did the UTP University in Toronto, guess what he used for the ceiling? It's a corrugated aluminium. And not a joke, in local source, corrugated aluminium, the supplier is Alcom, and it's meant for chicken farm. So they presented the catalog with the chicken and the cover. But it's done. Because it's Norman Foster, nobody contests, okay? So yeah, corrugated profile is interesting if laid horizontally, but Malaysia, because of the cheap kampong house, so this become overbearing in terms of its low quality. I've got an architect friends who supply the roof for the mom's house, and he loves this corrugation in color bond steel. It's not the cheap stuff. Sent to the site, the architect called me, hey, Mr. Lau, I have a big problem. What's the problem? My material already arrived, right? Yeah. My mom saw the material and tell me, son, if you have no budget, let me know. Why use these? Oh my God, I said I cannot solve your problem. So our signature dish come out again. You can use this, and this is widely used in Europe, okay? It's a European system. It's not Australian. Australian is clip-lock. It's true. Or the sinusoidal. Europe, they use this. So you've done this. Anyone recognize this project? You know, right? You've seen this in Penang, swimming club. Shopping mall, all right? Roof and wall. This is Alameda. This is a clubhouse. Okay, this overseas project. Show you image, but it's a standing seam system. It's a material that's different. This is a classic example. If you use ACP, it can only be in square block. If you want to do a curvature, what you get segmentation, right? It's going to be very, very difficult, not smooth. So using standing seam, you can have you can pre-curve, right? So this is something to think about as a solution. Here, what you see, standing seam, play around with the seam panel width, right? If you vary the panel width, you get a very different aesthetic coming out of the facade, like this. Not the same panel width, like this. And this is copper. This pre-patinated copper, very, very expensive. We have only done a couple of jobs. The most prominent one, the Sultan Aslan Shah Gallery, that I will show later. So again, standing seam system, like this, or residential, or like this. And this again. Here in Europe, they use a lot of aluminum, titanium, zinc. Unfortunately, if it's a masonry wall, fine. If it's a single skin wall cladding, aluminum, I don't think it will pass lah, for sure. Unfortunately, even titanium zinc, the zinc melting point is also very low, even lower than aluminum. But copper, yes. Copper can go up to 1,000 degrees. So this curved kind of rooftop, you know. So then again, not just those profile, we have also metal tiles, right? Metal tiles very popular in Europe as well. Three designed locally, diamond shaped, rectangular, and rhomboid. So you can install it as a system with insulation or without, as a single skin or with a masonry wall. So that's how it's like. There's always a metal deck backing. This is our office, our Louis Vuitton entrance. Right, I see a lot of Louis Vuitton diamond shape in their showroom, so we also get inspired. So this is a colorbond material. That is the dome I mentioned, the pre-patinated copper dome. Right, it's a diamond shape. So you can apply it as a roof. What can be used for roof can be used for cladding, not vice versa. Okay? So this Prime Minister's office, that's the beginning of SWISMA. SWISMA was born because of this project in 1997. So you want to take a guess, SWISMA, how the name came about? This is done by, this is the only project roof not installed by Indone, Bangla, Myanmar. It's installed by Masaleh. The Swiss, the German, the craftsman from German, the master craftsman from Swiss, because there's no such artisan trades in Malaysia. So that's why they want this design, and a businessman, the founder of SWISMA, wrote in this Masaleh, form a company. So Swiss, Malaysia, SWISMA. So today I always say we are SWISMA, Swiss technology, Swiss craftsmanship. So that's where we learn, all right? So this is a titanium zinc. It's pre-painted, but zinc is normally used natural. That's like copper. I would say it's a waste, but our Dr. M, do you notice that our Dr. M favorite color is green? Don't notice, huh? This was his decision. He wants it green, otherwise it would be gray, right? And wanted it to be in pre-patinated copper earlier, the same one that you see here. But this pre-patinated natural copper will have uneven color, as you know. Natural thing will have uneven color. If you see same color, don't believe it's natural, right? So he wants green. Then they're concerned that the color variation. So the interior is French, very Frenchy. They said very proudly, in France we use titanium zinc, so non-ferrous, same durability, but they want green, so painted. Again, I don't mind sharing. Those days I didn't know, they didn't want to say the color has faded. I was like amazed. Oh, how can this be disappointed? We were so ingenious. How can it be that color fading, you know, such expensive roof? They didn't want to tell. That's where when you have to understand the performance. A product that performs well in Europe might not perform the same in our country. European weather and tropical are very different. They use PU paint which can withstand that weather for very, very long time. Premium in Europe. Otherwise they won't offer. Not polyester, PU. In Malaysia, it cannot. It has to be PVDF minimum. So just sharing. So we also learned, we use a lot of European product, expansion joint, 10 years warranty, after 5 years brittle, under UV. Okay? So you really need to know your product. So this roof is like an undulating roof because of the optical illusions. This is this hotel. I haven't got a chance to see whether any signs of incredible hub happening, because copper is supposed to turn green eventually, patinate. Right? You see the ring was new, shiny, bronze color. As the weather, it turns darker and darker, almost black. So Tan Abu Samad building in KL, the historical building, is black dome. It's supposed to be a copper initially. right? So in Europe they will turn green, but in Malaysia, heavy rainfall, I think unlikely. The one that turn green is your hot water piping in your toilet. So don't go and scrub it off, please. That's not fungus, that's patina. So this images how you can use different kind of cladding system rather than boring rectangular square blocks. You can do this. You can do something like this, or this, or this, right? From white shape. Okay. So we have another cassette cladding, which is a simple interlocking. There are samples out there as well. The metal tiles also, we have a small mock-up out there. So the system of assembly is, it can be a single skin, like this cladding system, or this. This is a very challenging cladding system using color bond only. Or these are foreign project images. You can build this, like this, and ta-da! That's the end of my sharing. So thank you very much. So I think it is now on Q&A. I'll hand the mic back to the MC.
Oh, thank you, Mr. Lau. I'd like Mr. Lau to remain on the stage, and I also like to invite Architect Chong to the stage. Right now is the Q&A session. If any of the architects have any question, there's a mic at the center. Just go forward and pose your question. If you are too shy, then you can scan this QR code, and then I'll read it out your questions through the WhatsApp. All right? So, any takers for the first question? Come on, don't be shy. Anyone?
I have 3 questions for both Mr. Low and Architect Chong. First one is regarding the BS 8414. After the testing, who should sign the Form C1 and also C2? And also second question is regarding the system performance. How about the warranty? Who should be accountable for the entire system's warranty? Number 3 is regarding how Lombard conduct the inspection during CCC inspection. Thank you.
Okay, I'll start now. Architects are number on C3 lah. I'll answer C1 and C2. Then I'll jump straight to the last question. How does Bomber inspect? I don't know. Depends on which officer comes. And also how much involvement that guy had when we were doing the submission. If we do a submission rather non-conspicuously, I don't know. I really don't know. But in my case, I got bombarded because we went through every single stage of the design, the calculation. My clients went in several times. Because when we went for the testing, also the suppliers themselves, in terms of the details that they were designing, that they did it was rather generic. Also, as you can see on my installation, we had the variation of the cavity and all. So we actually put those drawings were actually the submission drawings. Right? So we actually have one whole stack of submission drawing just to support the BS 8414 testing. So of course they came they check every single thing. So it really depends on your, I wouldn't use the word luck, but it depends on who the officer comes and how much liaison they have to do.
If I'm not mistaken, we signed C2, I think, the manufacturer. C1 is the contractor. I've been signing. So switch, okay. So you sign C1, the contractor signs C2. So I'm also putting my head on the chopping board. So I think just on that note, there are some company who says, "Oh, my product passed 8414." You have to be careful when they say they pass. Or what kind of system? Does it match your own system? That is a key point. A lot of people take comfort that, hey, this manufacturer product pass A414. Without quoting him, I saw in the product catalog, this product is obviously combustible. It will disappear in part 2. And then they tell customer, hey, my product also pass A414 in general. And the customer say, hey, somehow their product also pass A414. I say, how can it be? Which part? He showed me the catalog. He didn't even mention part 1, part 2. He just said, I passed A414. I said, this is totally misleading. Right? A product like this will pass in part 1 because it can get out of the way, all the fire stop and all that. But that product is not for aesthetic application. So who would want to put this product over a plastered brick wall? So it's totally misleading to call your product pass 8414. And in general, a lot of irresponsible manufacturers, some of them they do, like this one, I won't quote name. And I will say, a paper cannot wrap fire, right? So sooner or later, all this will appear and it will make you look so unprofessional. But then again, now today after these sessions, I think all of you is so well informed. You know what kind of question to ask. I always say you don't know what you don't know. In one.
We actually have some questions to WhatsApp. Yeah. So the first one is, can I name the name? By architect Ziling. She's asking, what is the definition for cladding? Decorative panels on staircase, car parks consider cladding that require to pass the BS 8414.
Well, yeah. In the BS 8414, okay, it starts with the UBBL. It starts with the clause in the UBBL governing cladding. The description is that anything you put in front of the wall or anything you put as a lining to a wall. So in the original UBBL, it just says anything above 80 meters or nearer than 2 meters to the boundary, it has to be uncombustible or class O. So it just says the wall. And if you make a reference to an external wall also it says that to be fire rated, then only you go and look at the Schedule 6 on in terms of proportions of opening or non-protected areas. So the original intent of the external wall is that it should be non-combustible. That's really it. Of course now, coming to modern day, we have to adapt to so many different interpretations of what a wall is. Ultimately, there will be the function of a wall, and the cladding is supposed to be like a wrapping around the wall, anything you put in front of the wall. So BS 8414 testing is very, very specific, as you can see now. If you have a masonry wall doesn't necessarily just mean brick wall. It's any wall that's uncombustible and solid in nature. So reinforced concrete wall, shear wall, the wall in itself. And the cladding just forms a non-load bearing element covering the wall. Then, if the cladding forms part of an integral structure that makes up the wall itself, then you go for part 2 testing. So I think that's really what it is. Yeah, that's really what it is.
Hi, I'm Wei, architect Wei. Just a small question for either one of you. 8414 is recently put through. So you are, Architect Chong, you are under discussion with Bomba currently, right? To finish the red book?
Yes,
Okay.
yes.
So that means the guidelines are not comprehensively out yet, correct?
Well, the law is out.
Yes.
And of course, the standard is the standard. The standard is not the standard of the material of the cladding, it's the standard of testing. It's the testing standard. It is not a prescription of what you can do on the wall. So 8414 is actually a testing standard.
Okay. So effectively, this requirement for cladding testing came about by 2021?
The official directive was issued in around about 2021.
Okay. So how do you how does Bomba come around those buildings that were built prior to 2021, and as well as a lot of them are using cladding?
Yeah.
So what's the stand of the architect there then?
Yeah. Well, as what Lau has also explained, yeah, well, Bomba's intention is that they want to, of course the Gazette was supposed to be the Uniform Building Bylaws, but the one was coming a little bit late, so in August they couldn't tahan anymore, they said double day already, so they issued the directive. Yeah, but all this development was way back already. You went into it in 2019, I went to it at about the same time, that's why we cannot at that time. So we were used like a test case, I was like, okay, good. So the intention has always been there, and of course, in the eyes of the law, laws when it's gazetted, it has to have a date with effect, yeah, and retrospective. But our Uniform Building Bylaws the entire document for. So Bomba could not isolate that part. So what Bomba did was the directive actually mentioned that the August 2021 directive actually mentioned it is with immediate effect for all new building submissions and for buildings that have not been built as of the date of the, not completed as of the date of that, it is subject to it. So that's why during that time also there were a lot of projects, people got frantic because everything was really coming onto the site and they have to retrospectively get the test. Then as for existing buildings, they did say they want all buildings with cladding systems to be reviewed. And they're given 3 years, building owners were given 3 years from the date of the directive to ensure that the buildings are brought up to speed.
So my question, subsequent to this answer, so the fire license will be very important, the annual one, is that where
the
they check?
fire certificate?
Yes,
actually it should come in under that.
Should come in under that,
but
yeah, so most clients by now, like some built in 1990s, they probably won't know what cladding they have.
Yeah, it's true.
Other than it being faded, then they say, oh, high time to change.
Yeah, it's true. At the end of it, it's just enforcement already for all the I think a lot of fire certificates, a lot of my clients have actually gone through fire certificates and there was no mention. There was no specific mention. They mentioned a lot of other things, they're looking at insulated shutters and all. That turned out a lot also. Retrospectively, we asked, say, oh, I'm sorry, you have to change all your shutters, insulated shutters. But cladding has been noticeably silent.
Yeah, actually, just want to add to that. When Bomba said retrospectively 3 years, I say it's gone past 2021. Our test was 2019, 5 years now. For whatever it is, I don't see any action. I don't know. Maybe I'm not exposed. But in countries like Australia and UK, they seriously implement land lease. Maybe because of their effort now, they are for sale, right? They got to pump in all those projects. They did their own project to replace those cladding. Cost a lot, cost more. UK, the government is trying to push that up to the contractor, to whoever. But Australia government is taking some ownership together with the developer. So they are really doing it in those countries, but not in Malaysia yet. Okay.
It's stainless steel.
Yeah.
But it's high melting point.
Technically, should be okay.
Technically, you're supposed to test it, but I would say that one is okay because it's, firstly, it's stainless steel.
Yeah, the most important element is non-combustible.
Yeah.
You see, very ironical. I share another project. The project want to insulate cladding and roof is given. You have to insulate. The wall they want insulated, so they found so-called the most efficient way to provide insulation for the wall. They use the 3-in-1 kind of corrugated panel, right, with the PU laminated. So, ta-da, 3-in-1, right? Just like they say, the Rejoice shampoo 3-in-1 solution, in one step, finish. But then come to submission, unfortunately, it was turned down by Bomba because it is combustible. combustible. So the design was there, awarded, contract, budget, everything based on that. Despite that, they have to change, right? Correct.
Okay, we got another question from architect Yu Sheng. Does glass cladding system need to go through the 8414 test, especially that looks seamless on the outside that cover over the vertical barrier?
Okay. The specific application of BS 8414 is we are simulating the performance of a cladding system on the, from the effects of a fire breaking out of an unprotected opening. So the question would then be, that piece of glass that you're sticking on, is it over an unprotected opening or is it over a blank wall? So if the glass, like for example a curtain glass wall system, the entire wall is all glass, no? Yeah, you make the glass reflective, you can't actually tell where are the windows and where are the unprotected openings, and you can't tell where are the beams and where are the fire deflectors and all behind it. So technically speaking, the part that forms the window where the fire, where you're supposed to be able to see daylight outside, is exempt. The part that is over a beam from which when you stand on the inside you can't see through that particular component on the outside is subject to, is considered a cladding and subject to it. So the key element that both of us were emphasizing, that element, that seal, or how you treat that component at the window head, at the window seal is most important. So if you have a continuous curtain glass wall going all the way up, going past the window, going past the beam, or going past the structure, going past the wall, that cavity between the head of the window and the beam and the window below, that is your detail that has to be done, and that has to be tested.
Next question is from Chairman Patolo. He's asking, aluminium has a high expansion rate that may cause curvy, protruded, uneven surface. So he has three questions. Question number one, how to avoid this? Number two, how to allow expansion, especially at the fastener joints? Okay. And number three, how to avoid oxidation when fastener and cladding are different material. You need to repeat.
Okay. Depends on what kind of application. Like I said earlier, if you are thinking of using aluminum single skin on part 2, you can forget about it because it will not pass, right? It will just at level 1 because you have no masonry wall behind. The 6th criteria is there's no burn through. No burn through. Here is fire goes straight through because yes, burn off. So aluminum expansion, aluminum has got very high thermal expansion, coefficient expansion, almost 3 times of steel. So when it's a technical problem, there's always a technical solution. I would say technical problem is the easiest to address, right? Because you know the root cause, you can always design to address it. So again, depending on what specific kind of system you're looking at. And like I said, if it's for part 1, yeah, you can still design for expansion, but make sure that your gaps, because when you have expansion, you have gaps, right? Or you have something that is flexible. And usually flexible stuff are combustible, usually, unfortunately, unless you've got thin metal to allow it to move. So I mean, broadly, technical issue can always be addressed, even for roofing, right? What can be addressed? Roofing is even more serious because they're getting more solar heats coming down in the wall. So one way is, like I said, standing seam, allow for thermal expansion. We do have to allow. If you don't, then you see the buckling because you are restraining it. So it has to go somewhere, right? So normally it buckles. So I don't know whether I answered that question.
Maybe just to follow up on that, not on the aesthetic part, the mention of using the aluminium for the part 2 test. Well, aluminium, because of its, well, the reason why we've always been using aluminium, or we like to use aluminium because one thing is lightweight, it's very, very lightweight, and secondly, the aesthetics. That's why it's composite panel. They say aluminium, whenever we want to use it as a paneling, we always end up using ACP because we needed that lamination to give it a stiffness. Aluminium on its own would be quite flimsy. Yeah? So, of course, when before BSA 414, for the purpose of lightweight, even the structural framing, the mountings and all that, we want to use the benefit of the lightweightness, so we use aluminium. But aluminium, yeah, very low melting point, 600 over degrees, it starts to melt off already. That's the reason why we have to come up with a composite. If you insist on aluminium for its aesthetic qualities, first, the composite panel, make sure it's mineral wool, mineral infill, and then you really need to comply, especially on the falling debris and the structural integrity criteria. You cannot use aluminium, right? So aluminium would be really restricted to just the surface, the visible aesthetic surface. Right? So that's the reason why, like in car fires, if a proton saga burns, at the end of the fire, you can still look at the shell of the proton saga and you recognize, oh, it's the proton saga that burned. But if it's a Ferrari, after the fire, there's nothing left, because the aluminium is all melted on the ground, one lump. Right? So that's the reason. Aluminium is good because it's so lightweight. In terms of strength per weight, it's actually very, very efficient. But yeah, for purpose of 8414, as a structure, it will never pass the integrity test.
Yeah, talking about compatibility of the fastener, you say, right? Unless you talk about exposed screws, of course, naturally, the first thing that comes to mind is stainless steel, right? Most durable, because anyway, ACP is supposed to be installed with stainless steel, right? Because you don't want trouble from the screws. Just one thing to highlight: stainless steel is not the solution to all. Again, relate back to material. Stainless steel, I'm not sure whether all of you do know, is not so-called compatible with loose coat colorbond material. It creates black eye effect and it starts to corrode. So this is, in theory, yes, but because of the potential difference on the two material in contact with air and water, it becomes a battery. So this is a question that is usually I highlight because I've seen so many specifications. Those who are very mindful of durability, they put stainless steel screws. Then we have a challenge. If we supply the material, they fix stainless steel screw. We submit our warranty approval to Blue Scope. They say, sorry, it's not compatible, no warranty. Then, so you got to be very careful. Check with the suppliers for their recommendation. Very important.
Hello. Hi, my name is Saikit. I'm from Swissmart. I think I always learn a lot from Architect Chong as well as Mr. Lau. Okay, one question here, or two questions. Number one is, let's say I have a high-rise, 40-story, of course, right, obviously past 18 meters in height. It's all masonry wall or RC wall, but suddenly I want to create a clubhouse or sky lounge on the 40th floor. Doesn't matter 1 story or 2 stories, but using cladding. So do I need to go through that test? That's number one. Because I faced a real situation where there are multi-story car parks, and suddenly on the top of the car park, there is this multi-purpose hall using the wall cladding. So do I need to go through the test? That is question number one. And number two, same thing, if I have, let's say, exceed the 80-meter height, but I just use a cladding material and a small portion on the top. Let's say I want to cover the roof if only, let's say 600 or even 1.2 meter. So do I need to go through the test as well? Because the test also not cheap, right? Yeah, thank you.
On the uniform building bylaws, as I mentioned, the law is a law. The law cannot cover every single situation. The law is just one formula that everyone's supposed to fit, like a highway code. Doesn't matter whether you drive a Ferrari or you drive a Porsche or a Balenciaga, 110 kilometers maximum. That's it. Don't ask why, don't ask how. In terms of the prescription of the height, it's actually the height of the building, referring to the height of the building. So if you have any cladding on the height of the building is more than 80 meters, yeah, it comes under it. It's not that if a tall building, up to 80 meters you use class O, and then 80 meters above you go for BSA 414. It doesn't apply that way. So by that inference, once you have a building above 80 meters tall, any cladding you put on it will be subject to 8414. It doesn't specify minimum quantity in that sense. That's the bugger with all I know it sounds ridiculous, but the laws are all You might try and get a waiver and go in there as the architect and say, there's really nothing up there. I'm far away from all the openings. I'm using the cladding as my logo, my building logo. Oh, whatever. Don't say that, then Bomba will say, all logos must be tested. Don't open the can of worms. So it is on the basis by the height of the building and components on the building.
I just want to add on to that. In fact, these are common questions we face as well. Going back to factories, warehouse, right? Let's say the warehouse is brick walls, no issue, no facade. But then up there, the gutter, they put a fascia. 1.2 meter wide fascia, right? There's the tiny bit around, the ribbon around. So by definition, test. It doesn't make sense, right? Doesn't make sense, right? Because there's no window, no flashover, no nothing external covering the gutter. But by definition, test. So I was hoping, because it's my daily encounter, I was hoping also Architect Chong with the Architect Associations can maybe drill some sense to the Bomba to really have waivers on situation that really doesn't make sense to me. To me, doesn't make sense, right? Because the concern is flashover, spread from floor to floor. This is a fascia external 1.5 meter away from the building, covering the gutter. But you cannot escape. I mean, it just doesn't make sense to me. So you're smart, you call it fascia, it's not cladding. Alright, maybe that's a solution.
Maybe.
Yeah, but by definition, any external non-load bearing cladding, that's what A414 says.
It's cladding, not fascia.
Oh, okay.
And that would actually be the practical approach until we sort out a way on how to rationalize
There's
this.
no opening to burn up. So why you
Just make sure there's no people going up there with smoke and then drop.
So yeah, I mean, I'm talking about interpretation, right? So architecture, you think that facial thing will be exempted?
I won't say it's exempted otherwise, because it really comes down to the people who are, to the particular officer who will be vetting your plans. So, it is about education. It is about education. We do have a lot of dialogues with Bomba, and some of the dialogues we really want to go out there and jump out of a tall building with joy, because it was so frustrating. But yeah, it is one step at a time. I think the Red Book is really one thing that we want to get out of the way, and then from there we can then spend our time. But take a look at all these details. These are all part and parcel about sharing experiences, sharing details, and being rational about this. It is. Well,
I agree with that.
like what Isla have shared also, he managed to get away on the interpretation of a single-story factory. Fantastic. I think because that the whole idea of what we're saying is that it is testing the cladding on the effect of a fire burning out of an unprotected opening so that it doesn't spread to the upper floors. So if you've got no upper floors to spread to, for all intents and purposes, the whole building can burn down, I don't care, because there's nobody up there
Yeah, that was using the ceiling launching guidebook, but I think the UBBL is silent, no more multi-story. So I told the architect to hold on to that multi-story. They are single, even 100 meter is still single, right? It's true, right? I mean, you interpret based on what is stated, so you put to practice what you state, that's all. And I cannot put the project, but they got a waiver. Yeah.
I have two more WhatsApp questions. This is by Architect Jin Liang. So there's a two-parter. The first one is, will Bomba require the 8414 test to be approved prior to the approval of the passive Bomba plan? Okay. And then question number two is, the 18-meter height requirement, is it referring to the topmost occupied floor or the overall building height?
The answer the second one first. There are two primary references to heights of buildings in the bylaw. One is to the height of a building, and the height of the building, there is the bylaw itself does have a prescription of how to measure the height of building. It takes into consideration parapets, slope of the roof, and angle, and what's the median height to come up with the official height of the building for the purposes of fire safety clauses in the bylaw of Part 7 and Part 6. The other reference to height of building is the height of the topmost occupied floor. Yeah, and that one is made for references to when you provide risers, firefighting shafts, etc., etc. So in Part 7 and Part 8, only two references to height of building, that is the height of the topmost occupied floor, or the height as per the method of measurement in the prescribed in the bylaw. So that's one. What was the other one again?
The first one was, will Bomba require the 8414 test to be approved prior to the approval of the passive?
Yeah, because actually in my experience, we actually submitted the details, but the tests only come in when we submit for CCC. When we submit in the borang, we then have to prove it. When we submit the borang. So at the point of submitting the test, you just have to specify what you think, etc., etc., and you have to say in full compliance to BS 8414 Part 1 or Part 2. And you mark out the areas in which you intend to. I think today you don't have to go through what I did. What I did was I actually have to get everything in first before the guy actually approved my plans. Yeah, so now it is, you just have to say you're in compliance. Then it comes at the when you submit the C1, C2, and C3.
I just want to add on, because again, sharing my experience, we've been approached on project matters. So, like what they say is only CCC, doesn't mean you have pre-approval. So there are some who sit on the decision, and then after that they get panic. Oh, work in progress. Then when can we get a test? If you say 6 months, then Mantia, CCC over already, right? So be mindful of the time. But somebody asked me, I put in one for recent, still no answer yet, right, Eugene? Supposed to be 2 months, but officially we haven't been answered. So to get I just want to repeat again, the submissions for Q will only be effective once you submit your full set of drawings with full payment, bayar dulu, then you get your Q number, right? Not like you ask a contractor, go and pre-book while we think about it, no such thing, okay? Everything has to be ready, submit, and whatever you submit, make sure you construct and don't change again. That's a key point. So the way to manage upfront is, you put out a provision for 8414 tests, everybody is known about it, then you are in place. The trigger already there. If you're silent all the way and then suddenly you thought about it and you're in a hurry, if unfortunately the queue is 6 months, then your CCC, sorry.
And also we may want to have the contingency. What if that sample fails? We want to see tomorrow, today you tested and it failed.
Okay, there's one last question by Architect Daniel. Are ACP vertical or horizontal sun shading devices and window hoods that have no direct connection to window openings, are they exempted from the A414 testing?
Yeah, this question has been raised. I would say if the sun shading elements are independent, they are not continuous, it should be exempted because of the, technically they're not cladding. The cause of the flame spread of fire is actually surface flame spread. So if you have a continuous membrane, a continuous surface that is covering the wall, that would be regarded as cladding. Whereas if you got a single element that is placed in, which is non-continuous, I would say those are not regarded as cladding. That's my opinion. I'm not
to add on to that, another questions always asked in warehouse design or whatever. In high-rise you got window, so you got the treatment of the cladding, you know, it's very straightforward for multi-story high-rise. But for warehouse, again, it's sort of a conflict of the Bomba own requirement, what, 40% opening? So what do you do? A lot of opening, right? The wall cladding is full of louvers, and now they got new requirements, smoke vent. I see very innovative concept. Just to share, I don't know. So they become so innovative, they do window hood to allow ventilation because you've got to prevent the water, right? Because the louvers, no matter what, there is a limitation, triple band, whatever band. So if triple band means less opening means more louvers, right? So this one are so-called silently exempted, but that take up maybe 50% of the facade cladding, right? And the actual cladding is only 50% or less. But gonna test all these opening, the fires go straight through or out. No test because can't test show fail, you cannot test the opening. So what's the logic? I really so don't know. People ask me, hey, disallowed, so my test rig, I got louvers, you going to install your louvers? No, just my cladding only, that one is not my baby. And it cannot be tested. Even FRP skylights for wall is commonly used, right, for skylight, for daylight. But it will melt. It's a facade, continuous, but it melts, so cannot test. So only metal deck are tested for those warehouse, forming maximum 50% of the cladding surface. So again, I find it a bit not so rational.
Actually, like I said, the law is a marker. They have to draw the line somewhere. Again, the intention is to simulate. The intent, if BSA 414 is not meant to test openings, that's really what it says. It is assuming that when you have an opening, it's because you require it and it is legally, and your opening is legal in terms of the percentage of unexposed, unprotected openings, etc. And you need it because you need it for ventilation, sky, etc. So the window is recognized as the risk. That is really what it is. Any opening in the wall shall be the risk of which you are legally allowed to put in for that purpose. The testing is that the cladding shall not exacerbate or when you have this risk of fire burning out of opening, the cladding shall not be propagating that risk to the other floors or to the other parts of it. So in terms of which component is to be tested, you have to decide. If you put a louver, if you put a continuous louver over in front of a brick wall, and the brick wall have got openings behind the continuous louver, so you don't see the openings behind. That's how you just see continuous louvers and all these open louvers. So is the louver subject to the test? Yeah, it is technically. Yeah, the piece that's going in front of the wall is subjected to the test. The piece that's going in front of the window is not subjected to the test. That's really what it is. The law is like that, we have to.
Okay, we have one last one. So there's this product X example. Say this product X had passed this 8414 testing, but not class O, especially BS476 part 6 fails. So can this product be used for building that is less than 18 meters?
No. You say, ESA 414 does not say that your components must be class O or non-combustible and all that. It just tests the whole system. So if it passes the whole system, but that item itself on its own may not have class O, so you can't use that element for as a class O element.
Yeah, just to add on, because you said combustible material can be used for A414. No, but melt away is a different thing. It's not combustible. The thing is, granite wall, right? Things like that. Will it be subject to test?
No, that's the big problem now. Because technically, if you hang a granite wall on the same way we always hang granite walls on masonry facades, we have the channels, we have the hooks, and then we clad it on. Technically, that's a cladding. It has to go for ASA 414. Technically, that's what it is. That's the real bugger now.
So the system, from my understanding, is because you have a cavity, right? The cavity is a chimney that propagates fire. So the way to overcome is to have a lot of stop, put the traffic police every floor. Okay.
I would say technically, to avoid it being cladding, technical, again, this is where it comes in terms of the use of words. So if you're going to have a granite wall, if you're going to have stone cladding, of course the way to mount it is you have the mechanical mountings. Right? So to avoid it being called a cladding, fill it with the non-combustible filler. Really, I'm serious. Then it becomes like tiles or mortar. Then you don't have a cavity. Then it's not a cladding, it is a tiling.
Your support fails.
That's the whole idea. Make sure your support doesn't fail.
You will melt under the 650.
Do not use aluminium. Anyway, don't use aluminium for granite tiles. The end it's too flexible. If use steel mountings, steel pins and all that, and fill up. You don't have the cavity there, so I'm tiling them. Like how China builds their buildings, they use toilet tiles on the external walls, so they're tiling. Don't say I say this.
Off record. Everybody got to sign confidentiality as you go up.
That's the privilege of being in the seminar. Okay, sorry.
Anything to add on the both speakers? Any more questions?
I just heard and understand you have a great book, right? Great book. So in here today, I also hope I get a copy, despite I'm not an architect. Because that guideline is really, truly supposed to help everybody when they do the design. So I don't know whether your red book timing came after the America ban on the TikTok, because they're all going to Xiaohongshu now. So if not careful, they said the red book is a Xiaohongshu. Just joking.
We change it to the green book.
Okay, before we proceed to lunch and the group photo, I would like to invite Grand Mountain Chapter Chairman Dr. Law to the stage to pass some token appreciation to the speakers. So I'd like to invite Mr. Lam, representing SUSMA. I'd like to invite Blue Scope representative to the stage. your smiley faces. We have a group photo here. Okay, look at the MC, huh? Alright, 1, 2, 3. Okay, one more. 1, 2, 3. Alright, some freestyle from the architects. Everyone, some freestyle. Alright, 1, 2, 3. Okay, great. So before we conclude today's session, I'd like to remind everyone again, the lunch is prepared at the ground floor, Saki's restaurant. Just go to the, just take the lift, go to the ground floor, it will be on your right hand side, okay? And last but not least, we actually prepare some gifts, but these gifts comes with a tiny little bit of sacrifice. Yeah? Just fill in this survey. Alright, once you fill out the survey, you can actually claim the prize just right outside the registration counter. Okay? So with that, I'd like to say thank you for your time and we hope to see you soon, everyone. Alright, thank you so much. And lastly, don't forget to sign off from your registration for the architects in order to claim your CPD points. Alright, don't forget to sign off. If you don't sign off, then today wasted time really lah. You get education, but you don't get the points. So reminder, yeah, do sign off.